Bismillahirrahmanirrahim. Assalamu alaikum. So we have already done linear graphs and quadratic graphs. So let's do some cubic function graphs today, and let's see how the cubic function graphs are different from the linear and the quadratic graphs. So let's take a very simple example. Sorry. Y is equal to x cube. A very simple cubic function, okay? And we're going to take some values and for this polynomial, and then we're going to plot those values, and let's see what kind of a graph we are going to get. Okay, so x and y values. Now, starting with 0, if we take x equals to 0, x is 0, so obviously y is going to be 0 as well. Okay. Now, let's take x1. So, it's simple. 1 cube is 1. 1 into 1 into 1 is always 1. So, y is 1. Now, let's take negative 1. Now, negative 1 into negative 1 into negative 1. So, negative 1 into negative 1, positive, and then positive 1 into negative 1, we get negative 1. So, this is the point where it's going to differ from the quadratic graphs. In quadratic graphs, of course, we have the function, squared function. Like if we have x squared, we give the negative value and we get the positive value for the y. But in this case, we're going to get the negative value for y as well. So now let's take 2. 2 into 2 into 2 is 8. And minus 2. Now, same as minus 1. Minus 2 into minus 2, 4. And 4 into minus 2 is 8. Negative 8. Okay, so we have values now. So let's plot on the axis. Okay, now we have axis, x-axis and y-axis. If you are drawing on a graph paper, what I have done is 10 small squares equal to 1 unit on x-axis and 5 small squares for 1 unit on y-axis. Okay, now let's plot these points. So first point is 0 and 0, which is origin. So this is the first point. Then 1 and 1, it's here. Minus 1 and minus 1, it's here. And then it's 2 and 8. And then minus 2 and 8. It's here. Okay, now let's join the points. Okay. This is our graph of a cubic function. Now, when we drew the graph of the quadratic function, because of the quadratic nature of the equation, we got the parabola. And in this case, because of the nature of the cube function, we got the negative values. So, we can see the difference over here, that for the negative values of the x, we got the negative values for the y. And so, the graph is also in this quadrant, okay? And this is our graph for the cube function, which is, we have taken it a very simple function. Now let's make some changes to this function, and then we'll plot again the points and see what's the difference is coming, okay? And yes, one more thing. before I erase this thing. Well, you can see that in this case of the cubic function graph, the graph may intersect x-axis once, or it may intersect x-axis to the maximum of 3 times, because it's a cubic graph. But in this case, what happened? Because it was passing through the origin, so it is passing through origin and it is intersecting the x-axis at 0. It's only intersecting at one point, and then we'll also take the example where it intersects at 3 points as well. Okay, now let's take the next example. Okay, the change made to this function is that addition of this positive 3. Now let's see what's the difference this change is going to make on our graph. So because of this change, now when the x is 0, y is not going to be 0 now. Plus 3, so it's 3. When x is 1, 1 plus 3 is 4. X is minus 1, minus 1 plus 3, 2. X is 2, 8. 8 plus 3, it's 11. And x is minus 8. Because of this minus 2, this thing is minus 8. And plus 3, it's minus 5. Okay. So we have our points. Let's plot these points and see what the change is occurring. Okay. Okay. So first point, x is 0 and y is 3. So this is the first. 1 and 4. 1 and 4. This is our second point. Minus 1 and 2. Two and 11. And then minus 2 and where is it? 5 here. Okay. Now let's join them. Okay. If you can just compare it with the previous graph, now you can see that this graph, this graph is now 3 units above the origin because of this plus 3, the change we made. It's very obvious that we made a change of plus 3, and it can be seen here. It's above the origin and 3 units above the origin. And this graph, this is this point, okay. So just to make it that it is passing through this point, okay. Okay, and you can see here that this graph is intersecting x-axis at this point, okay. It is intersecting x-axis once, but as I have said, we'll do the example where it intersects maximum to the 3 values, so it can intersect the x-axis at 3 points because of x cubed. Now let's make another change to this function, and now then we'll see what change is occurring. Instead of plus 1, what I'm going to do is minus 3. So what change do we get for the y values? Okay. So if I take 0 and 0 minus 3, it's minus 3. 1 and minus 3, it's minus 2. Minus 1 and minus 3, minus 4. 8 and minus 3, 5, and then minus 8 and minus 3, minus 11. Okay. So let's plot these points. So 0 and minus 3, this is the first one. 1 and minus 2, second. Minus 1 and minus 4. Okay. 2 and 5. And then minus 2 and 11. So let's mark one more point over here. Minus 11. And then minus 2 and... Okay. So we have plotted our points. So let's join them. Okay. So we have our graph for this function. Now what's happening? Because we subtracted minus 3 from x, so it is 3 units below the origin. 1, 2, 3. Okay? It's passing through minus 3 because of this, right? And then again, we can see that it is intersecting x-axis at one point. And if you want to calculate it like this function, so you can see if when y is 0, so it will be like 0 is equal to x3 minus 3. So x cube is equal to 3. So x is equal to cube root of 3. And you can see that you will get the value approximately 1.4 or something from at the point where it is intersecting the x-axis, and which is also evident from these graphs that it is intersecting at least once the x-axis. In the first case, it was intersecting at origin. In the second case, it was intersecting the negative x-axis. It is intersecting the positive in the third case. So at least once. Okay. So this was the graph about the cubic functions.
Allahu Akbar, Allahu Akbar.
Yeah, we're going to do some more examples, but in the next video. For this, I hope that you got the idea about the cubic function graphs. Thank you.